Good morning, Abinash. I hope you have no problem in reaching here. Let's start the conversation. You know that approach decision in system design is very critical, and to backing up your decision with facts require estimation. So I have one problem for you. Let's imagine you want to design a service like designing a photo sharing service. Let me know your approach for making back of the envelope calculation for the given problem.
It is really a good question to start the system design interview discussion. First of all, thank you to you and your team for giving me the opportunity to come over here. Designing a photo sharing service like Instagram or Flickr requires a lot of capacity planning. Here is a back of the envelope calculation for such a service. The first thing is like user traffic. Assume that 1 million users in the first year with 50% year-on-year growth rate. So this is a basic statement, okay? So let me repeat again. Let's assume that 1 million of user in the first year with a 50% year-over-year growth rate. So resources is like web server and application server to handle traffic. You might need multiple instances or even multiple zones depending on global reach. Now exact value I will come later, but for now this is the first point. The second is photo upload. So estimation we can do like on average each user upload 5 photos a day. Each photo is, let's assume that 5 MB size. So daily 1 million user and 5 photo, okay, per user. And each photo is 5 MB per photo. If you calculate it, it roughly comes around 25 terabyte per day. Let me repeat again. On an average, each user uploads 5 photos a day. Each photo is 5 MB size. So daily is equal to 1 million user, which is I already told you, into 5 photo per user and 5 MB per photo. It is roughly comes around 25 terabyte per day. Third is storage. So assume photos are stored for 5 years. Now, each year you need 25 terabyte, correct? No, each day, sorry, 25 terabyte each day. Now let's calculate for 1 year first. So that means that you have to calculate with 365, multiply this with 365 days per year, right? And then for 5 years. And if you calculate roughly, it will come around 45.6 or maybe 46 petabyte. So this is the storage requirement of these. All right. So now let's consider the photo views. So in photo views, let me explain you what kind of resources you are using. Basically in photo views, you are using as a data transfer requirement, right, between the client and server. So for estimation of this kind of, how much resource you need in photo view, let's assume each photo is viewed 100 times on an average over its lifetime. Lifetime say here is 5 years. Total data transfer in that case, let's assume each photo has size 5 MB. So 5 photos into 5 MB and 100 views. If you roughly calculate this value, it will comes out to be 2.5 GB per user over 5 years or lifetime. Okay. Now for one user, it is like 2.5 GB per user over 5 years. So for million users, it would be like 2.5 million GB. And that would be equivalent to 2.5 exabyte, right? So this much data transfer happened for your photo views. Another operation is database operation. This also again you require how much data storage required in database. For that, again we go for let's say photo data is one thing, that is a storage separate requirement, not the database. Let's say user metadata, likes, comments, etc. need storage here. So assume each user generates 500 KB of metadata and other data per day. So daily it will roughly comes around 1 million user, right, into 500 KB, which is 500 terabytes per day roughly, right? So over 5 years it will become 500, and then if you calculate exactly with the 5 years, it will come around 9.13 terabyte. Okay. So this much storage, database storage for metadata you need in 5 years. Similarly, you can calculate the network requirement also, right? Network resource requirement. So let's estimate for this network requirement also, assuming peak usage time in this service becomes 10x the average hourly traffic. So whatever the average hourly traffic we have in peak time, it may go to 10x times. And considering both uploads and metadata operation plan, bandwidth accordingly we require for all these operations. So you can roughly calculate how much network bandwidth you need for those kind of data transfer, like how much metadata is transferring and how much photo viewing is providing is needed your network. So by that way you can calculate this. Another point of calculation, maybe estimation point, is caching requirement. So popular photos, like in set of photos, some photos are like celebrities photo, maybe the popular photos for that due to some event, some photo becomes very popular, or something like you heard at something becomes viral. So especially those for trending or famous user will be accessed frequently, right? So let's assume 10% of daily photos, which is around 2.5 terabyte, because if you remember 25 terabyte was the total and 10% means 2.5 terabyte are need some caching here. So this much 10% I'm assuming that need caching. So that is a roughly approximate value. So these are the rough estimation. I think this is enough for initial understanding. And high speed caching solution like Redis or Memcached to reduce database load. So those kind of approach also you need to apply, but for that we can think of some more level of detailed observation of requirement, then we can estimate on those sites, right? Okay, so let's consider few more features, few more key points to under the estimation. Something like real-time features, suppose like comments on photos and so on so forth, right? So assume that 20% of users are online at any peak time and each generates 50 kbs per second of real-time data. So on that rate, your peak data calculation would be like 2 million users into 50 kbs, which is roughly around 10 gbs per second, right? Another key area which we should consider as an architect is redundancy and backup requirement for fault tolerance or maybe high availability for those kind of scenarios, right? So storing backup of all photos and metadata, assuming a redundancy factor of 2x, meaning double. So total storage required are double, right? Then if you want to optimize the storage requirement, probably the one estimation or one thought may be compression and compression of images, right? So let's assume that you decided to put the right level of compression tools to reduce the size of photo without significant loss of quality. This is as per requirement. This will definitely decrease your storage requirement and bandwidth cost, which is very important consideration as an architect. Another consideration would be security. Definitely, when you are working with the data, the challenge is security, and there are two key challenges here. One is security while data is transiting in transition, and security at the rest. And for that purpose, probably there are different technology, maybe SSL, TLS. These are the technology through which you can use the encryption logic to put data safe at rest or while transiting. So these are the basic points to consider when you discuss about the estimation back in. Thank you. Thank you for completing this video. And I hope that you definitely have learned something which will help you in your system design interview. Hope to see you in next video with new concept and skills needed for the system design interview. By then, keep learning, keep improving, and keep sharing your knowledge, because even if it helps one person, it will be worth sharing with mankind.